Charles Ivie to stage, who is a senior graph architect at Amazon and the premier graph database behind the Amazon Neptune, basically. A little bit of history of Neptune. I'm very impressed by how it came to be, at least from what I know about its history, is that one of the things that is actually very common with the Origin 12 community, because it's an open source graph database that people have been using, it's called Blaze Graph, was one of the kind of the best graph databases at the time, and actually got bought up by Amazon and turned into Amazon Neptune. Now, people have been very, very positive about Blaze Graph. You can only imagine what a much more improved, further built product that's tightly integrated into Amazon can do. So, thanks to Charles and his team, and super happy to hear your talk. So without further ado, and not taking any more time because there's not a lot, please take the stage and take us through it. And a small round of applause, please.
Thank you, man. Sure.
And then later, the big one.
Hello. Where are we? Yeah, so my name's Charles Ivie. For those of you who don't know me, Bran just told you most of it. I've been working in graph technologies for about 15 or so years, which is longer than most. But we're going to talk a little bit today about some of the origins of where all of this stuff comes from. I don't know how many of you know how long it is that the human race has had the same cognitive ability as we all do today. Well, it keeps getting revised back. So, first of all, we used to think that it was about something like 20,000 years ago. But then some people found some evidence. They found some data, and they trusted it a bit, enough. So they put that together, and they put it back to 100,000 years. And then some people found some more data, and they put it back again to 300,000 years, which is like, I think, the current official number of about how long it's been since people could think to the same degree that we all can think. So they could have had just as complex conversations as all of us do, apparently. So who knows what they were up to, really? Anyway, that's been revised back. Apparently that might be wrong now, because some DNA evidence seems to suggest that that can be pushed back to about 800,000 years. And what does that mean? That means, actually, that the origin of data being communicated and shared between human beings for the benefit of their children and their community and their civilizations has been evolving for that long. And if we take a step back and think about what data actually is and what that means, what data is, that's basically what it is. It's the exchange of information between human beings so that we can evolve to build better things. So data is nothing new. Knowledge is nothing new. But it's not much good if you can't communicate. And we can't pass on our knowledge to the next generation if we don't know what the previous generation said. So that means that we need to do a few things. We need to trust the origin of that data to a certain degree, because otherwise we might think that they're lying, which they might be. And we need to be able to translate it and intercommunicate. We need to be able to actually pass on the information effectively. Some of you may recognize the big stone on this slide. This is the Rosetta Stone, which was created in 196 BC, so over 2,000 years ago. Does anybody know the provenance of where this was found? Anyone? So, interestingly, the Rosetta Stone came from, there was a French soldier, I can't remember his name, but there was it was quite a while ago, there was a French soldier who was putting together a fort somewhere in Egypt. And as he came to the fort, they were pulling this down, this old building, a building of nothing, a sort of a communal random building. And he came across this as one of the building bricks. So it's fair to say that it doesn't really come from a particularly authentic source, necessarily. I mean, this is basically a brick in a wall. However, the data that it contained that could be verified from the languages that it translated on that piece of tablet verified its authenticity. So we were able to use that to translate ancient hieroglyphs into English via ancient Greek. So don't underestimate the power of authenticity of data, of knowing the origin of things, and being able to validate that. And that's really all that data is. It's the passing on of information to the next generation to make sure that we can build a better future. And it has to be based on authenticity, because if it's not, then how can we go forward with confidence? Anyway, but the problem is with this isn't the real one. So I built this with an AI construct. So don't try and translate anything, because it doesn't make any sense. It's a hallucination, like the other 14 bricks that they didn't use from that building back in those other so many years ago. So anyway, this ability to communicate is fundamental to all the technologies that we work in as well. And some of you who are a bit entrenched in the graph database community, which is basically, I think, well, I'd say at least some here, we may know that even within the graph database community, there is some competition. There's people that don't necessarily even want to integrate their data together because they come from different paradigms. There are the cool hipster types that come from the label property graph side. And there's the academic geek types like me and others who come from the semantic web side, far more from academia. And the thing is, what we really need to do is we need to get everything to interoperate together, to communicate so that we can build a better future, a more authentic future of data. So we know this at Amazon, and we've been working together to try and make that work and to try and join together different data sets to be able to interoperate so that you can do things like join them onto a decentralized knowledge graph and combine data no matter what the language you want to speak. So this particular example I'm going to show you today, it gets a little bit techie. I'll try not to labor too much on the code and that sort of thing. But we're going to show two different types of graph today going together to form a more authentic, a more complete picture of data about aircraft incident reports across the sort of industry. Don't worry, this isn't real data, so you don't need to worry about your flights home or anything. But we're going to have two graphs of data. One which is an ontology, which contains data about aircrafts themselves, their specifications, all that sort of thing. And the other is going to be a corpus of documents which contains incidents that have happened over time, but they're all fully free-form text. So two very different types of data, one completely well-structured and one completely unstructured, really, at this point. But we want to join them together. And for those of you who like to get your hands on the keyboard, you can do all of this at home. So there's nothing here that I'm showing you that isn't available to use as an open source piece of technology. So as much as I would love you to do all of this on Amazon, and I can tell you many reasons why that's a fantastic idea on AWS, you don't have to. You can do this on your laptop at home. The three components of that we'll be putting together, that I've put together here, are the Graph Notebook, which is a Jupyter notebook, which is open source, which you can use for any graph database, so not just Amazon Neptune, but any other. The GraphRag Toolkit, which is a self-contained toolkit for GraphRag, which, again, you can use with any graph database underneath. And a Graph Explorer, same deal. You can use it for any graph database, not just Amazon Neptune. So we're going to combine our two graphs together to try and create a combined graph. And we're going to be looking at various different things across those two graphs to join them together. And we're going to be comparing things using MCP and using all the wonderful new things which we will hear about so much now to combine together data sets with natural language interfaces and language models and so-called artificial intelligence. One of the techniques that we're going to use to do comparison is something which we call semantic fingerprinting. That is, if you want to compare two words together, it's quite easy to do so, but they can mean completely different things. Really, what we want to compare is networks of things together and their similarity. So they could be called very similar things, but they could mean completely different things. So we use a sort of semantic fingerprint of these two different entities to join them together, to join entities which we find in the graph of the corpus of documents, the free-form text, to that which we have in our deterministic knowledge graph. So I won't labor on this too much, but the GraphRag toolkit, if you want to go and use it, is very easy to use. There's full instructions to do so, so please do go and download it, and we're very keen to see how you find using it, no matter what the technologies are you're using. So how do we actually combine these two things together? Well, the first part of it, one piece of the puzzle, is something we called, well, many people call a lexical graph. A lexical graph because it is purely a dissemination of the text to understand its meaning by the entities that are contained within it, statements about those entities that support facts that we can infer from it. So the more documents you can apply to the GraphRag toolkit, the more authentic you can believe their rhetoric to be. The more evidence you have, the more confident you can be in its opinions. So that's one graph, that's a lexical graph, and that's very different to the knowledge graph. You know, this is really about creating a graph to have a structured form of an unstructured set of content. The other one is the knowledge graph about it. So we're going to be basically taking as well a set of data from an open source RDF database, an open source ontology, so some data which we believe to be reasonably authentic already, which is being combined and collaborated by a community of experts within the industry, and just transform that straight into RDF. In this demo, we happen to use Bedrock. There's many other ways, some of which you'll see later on tomorrow. So we have two graphs, and we're going to join them together. And we don't necessarily want to have different ways of querying them. So we've been developing at Amazon, we're developing a new way of working, which we call OneGraph. OneGraph meaning we really want to be able to query both at the same time. This is still very much at the beginning of what we're creating, but even now already, you can write in our OneGraph solution in Neptune Analytics, you can write a cipher query, which is actually a language for label property graphs, and query RDF. So those of you who'll be familiar with it might notice things like prefixes, which only exist in the RDF world. So we are getting those two communities to talk together, even if they don't want to. And of course, we're using LLM and MCP agents because everybody does. And one note about MCP agents. There's lots of talk that goes on about MCP. Is it good? Is it bad? What's wrong with it? What's great? I think for me, just as a side note to this, everything that we talk about and that we have talked about today already is about interoperability, about trusting the source, but that also goes towards trusting the sorts of models that you use to integrate your software. MCP provides a standardized interface, just like Ethernet or many other things, so that we can at least plug in software easily. So it's great on that face, and that means that it's easier to build software, which is a damn fine thing. So here's some code. It does some stuff. If you want to go into it in more detail, please do. But basically, we're calling a couple of MCP agents and we're calling the tools by name so that we can get responses back from the different applications. Because really, we're actually going to compare two different ways of doing this. So yeah. More of the same kind of stuff, but we're going to compare something slightly differently in the end in the demo, which is that we're going to have a look at the sorts of information you can get back just from one graph, which is just the lexical graph put together from the documents. So if you like more of a generalized RAG implementation, more of a traditional one, and one which is a GraphRag implementation, which is combining the two. So hopefully giving us more information, more authenticity, more provenance and lineage of the data, and that sort of thing. So hopefully, if this demo works, which I think it is, yeah, this is a video, it's not really a demo. Anyway, so what we've got on the left is the knowledge graph chat, which is the combined power of the two graphs together, and what we've got on the right is just talking to the corpus. So on the left, we're asking what kind of aircrafts are in the database. We're asking the same question on the right-hand side. And what we hope to see, what we expect to see, is that we have more information on the left than we do on the right. And we do. There's a lot more information about the specific types of aircraft, where they come from, particularly in relation to the data set, to the joined data. This isn't fast enough. This is probably the most boring query as well. And then we get to the next query. So when we say something like, tell me about a specific aircraft and their specifications, and, oh God, I should have put this on fast forward. And we should get some seriously detailed specifications about the aircraft from the combined knowledge of the two graphs on the left-hand side, and we get a much less verbose, more generalized description of what's there. So that can give you, for example, just a brief example of how much more information you can get about the information that you already have by combining existing knowledge graphs to your unstructured content. Yeah, that's really the end of it, pretty much. This goes on for about another 3 minutes. I don't have to put you through it, and the text is quite small. But yeah, that's it. So I hope you enjoyed what I had to say. Thank you.
Awesome. Thank you, Charlie. I'm going to try to avoid the microphone thing, but before you leave, we have time for one question, if anybody has a question. If not, Charlie will be with us still, not just throughout the day, but we also have a panel together very soon. So there will be opportunities for questions again. But if somebody has something on top of their tongue right now, this is the moment to shine. There's one.
I'd be very curious if you had any lessons or learnings from applying, graph rag and basically things to agents and stuff, and where you kind of see that going, what you see the limitations or opportunities there.
I think that MCP provides us in one way of creating a good barrier to an interface to a degree. So it allows you to work to a certain degree in isolation on a particular task. What I like about this GraphRag toolkit implementation is the lexical graph can live on its own, live and breathe on its own, and not necessarily be, and you can engineer that in isolation compared to the others. So I like the way generally that it's going. Like I say, I'm a big fan of following standards. I don't mind that it's not perfect, because what is, and it should only get better, hopefully.